Okay, so in this video, I'm going to do a little bit summary on physical optic, topic 7. So here you can see I separated between interference and diffraction. I do it side by side so that you can see clearly how to use the formula. So the formula looks quite similar, except this one got D, this one got A. And then for this one, for interference, the top part is for constructive, and then this one for destructive. Okay, you can see that for constructive just M, and then destructive M plus half, and then that one is opposite to this one. I think formula should be okay. And then you have, instead of have delta Y, for diffraction you have width of central bright maximum, which is this one, which is 2 lambda D over A. Okay, now you have to be careful on how to use this formula. So for example, if they give you numbers of order, that one is straightforward lah. You just have to substitute all numbers of order as your M, so you don't have to do anything. But only for destructive interference, if they give you numbers of fringe, you have to minus 1. Example over here. Okay, so over here you can see the numbers of fringe is 1, the first fringe, and then numbers of order is actually 0, so you have to minus 1 only for this one, destructive yang double slit. So if you can separate between these two, then it should be straightforward. And then at the same time you have for diffraction grating. So this one, that I always told you, you have to be careful with this one. So normally they will give you N not in SI unit, so you have to convert first to meter. Sorry, you have to find D first, so that you can have like centimeter or millimeter, and then only you convert. It will be much easier compared to you convert it first, because initially it will be per centimeter or per millimeter. And then sometimes they might ask you to calculate numbers of fringes. So numbers of fringes, you have to be careful lah. Let's say you calculate like this, and then you get like M equals to 2. So let's say this one is M is equals to 1, M equals to 2. You have to multiply by 2 so that it will be up and down both sides. So numbers of fringes, okay, let's say you calculate kan, you got M equals to 2.88. So what you're gonna do, you have to round it off to before, which is 2 as your solid number, and then you have to multiply by 2, so it will be, and then you have to add 1 for the center part. That one is for the bright fringes, so it will be, so it will be 5 fringes. Okay, so 2M plus 1. Please remember this. If they ask you to calculate numbers of fringes, maximum number of fringes or something, okay, especially for this one. So maximum sine theta is equals to 1. You calculate numbers of M. Let's say you get M equals to 2.5, 2.8. You round it off to 1 to round number before, and then you multiply by 2, and then you add 1, so that you can get total numbers of fringes, bright fringes. Okay, now at the same time you have thin film. Thin film, like I always told you, please draw 2 lines. Okay, and then you have to read the question carefully, and then you identify which one is N1, N2, and N3, and then you list it down like this. Okay, if the numbers in sequence, whether it's increasing or decreasing, so it would be in phase. So in phase, you just use this formula, M and then M plus half for destructive. And then if the numbers is not in sequence, like this one, you can see that increasing and then decreasing, you have to consider that this one as antiphase. So let's write it down for you. Antiphase interference and in-phase interference. So for antiphase, you have to the formula would be opposite to the in-phase. So constructive, you will have M plus half. Destructive, you will have M. And then normally the question will ask you to find T minimum thickness of the film. So that one, that means you have to consider like the T minimum when M is equals to 1 for this formula, this particular formula, because you can substitute 1. Okay, if you substitute 0, then T will be 0 as well, so it doesn't make any sense. So for this formula, you have to substitute M equals to 0, because you can substitute M equals to 0. Okay, I think that's it for the physical optic. I'm going to go through the questions for passé question. Yeah. Okay, for passé question, you can see that, let's say we are going through question number 22. Okay, they divided into 3 parts, A, B, and C. You can see clearly A is for young double slits, is it? Through 2 narrow slits. So young double slit, and B2 is for thin film, and then the C is for diffraction, and in this case it will be diffraction grating. Notice that I told you about N equals to 400 just now, so you have to do like D first, and then only you convert to meter. And then yang B2, you can draw 2 lines, and then you decide which one is N1, N2, N3, and then you decide whether it's constructive or, sorry, in phase or anti phase. And this one is more like physical, sorry, this one is geometrical optic. Okay, for this one, 2 narrow slits separated. This one is young double slit. Okay, and then distance between the edges and bright fringes on the screen, that one is delta Y. Distance of the 5th dark fringe. So they give you like 5th dark fringe, so you have to be careful. 5th, so that means M is equals to 4. But they want you to find distance, right? Yeah. So I strongly suggest you to draw the pattern first so that you can see clearly how to solve it. Question B, single slit, that one is for diffraction. Question 1, they ask you to find A. B, they ask you to find Y. 19A, young double slit. 19B, thin film. Okay. 18A, diffraction grating. Calculate the slit separation, maximum number of bright fringes. Here where you have to find M and then round and off to 1 round number before, multiply by 2, and then add with 1. Okay, B, and then how can the numbers of bright fringes increase? This one for the pattern, and for the numbers of fringes, you have to find a formula, and then you have to state the relation between number of fringes and the and the quantity that you can increase lah. Okay, B. Okay, this one is more like a concept, initial one. So constructive or destructive interference determined by whether when you deduce so you have to be careful. This one, it says that coherent lights, so you have to think a little bit whether it's in phase or anti phase when it starts, and then the difference between those delta L, whether it has half or doesn't have half. Okay, you go back to the basics for this one, the C, and then they want you to find the thin film. Okay, this one is for thin film. Soap bubble should be anti-phase. Okay, and then question 17, you can see clearly figure 7.6, you have N sat 1, 1.38 and 1.61. The number is increasing, so that means this one is in phase. Okay, I think that's it. I think that's enough for physical optic.